Hello everyone. Today we are going to look at a very important topic called orientation of third substituent into the benzene ring. It is usually more difficult to predict the major product when a disubstituted benzene undergoes further substitution. However, we are going to follow certain guidelines. See, when a third substituent like Z plus this electrophile is substituted, this position is possible, and this para position, this position, and this position. But the group already which is present with the benzene ring needs to be analyzed. This may be ortho, para, or meta substituent, and so is this B group also. So which will dominate, which will be suppressed, we need to know. So we are going to follow certain guidelines using which we can able to make predictions. So when both groups are ortho and para directing, the groups which are already present on the benzene ring is ortho and para directing, then the more powerful group that will control the orientation of the incoming group. So we need to know the order of these powerful groups. It is given like O minus is the most powerful one which will force which will direct the third group. Then comes NH2, then comes NR2, then comes OH, after that methoxy group, then comes NHCOCH3, then comes CH3, finally comes halogen. So this is going to be the order, right? Now let us take the first case. Here I have OH group, and to the meta position chlorine group is there, right? OH will direct here and here, then here, whereas chlorine will also direct the same positions. Yes, it's ortho, but OH comes first in the priority, so which means OH will dominate. In that case, the substituent will go to the para position to OH. So this may be the product that may be obtained. That will be the major product. Right? Your Z will attach here, your OH will be here, and Cl. This will be the major product. When I come to the second case, OH and Cl, the influence are opposite. They are opposing. OH will force the direct the incoming group to this position, whereas chlorine will force them to here. But these positions are not favorable, because OH will dominate the directing effect of chlorine. So your Z may attach ortho to OH only, which means we will get this product as the major product. And when it comes to the third case, this is para to this one, and the chlorine's effect will be suppressed. So para isomer will be the major product. So chlorine will be here, ortho will be here, and Z will be directed to the para to OH group. So if both the groups are meta directing, then it is very difficult to introduce a third group in the benzene ring. So the directing power of each group is generally follows this order, which I have given here. Trimethylamine is much greater than NO2 group, then cyanide, then SO3H, then aldehyde group, then acetate group, and then finally COOH. The important point to note is here the less powerful group will control the orientation, which means in the given example I have aldehyde and acid group, and acid will come as the least priority one, which means that will have greater dominance over the directing influence, right? So COOH will direct this one. So the Z group will, the incoming Z will get attached to the meta position to COOH, which means this position is preferred, right? So this will be the major product. So your COHO is there here, COOH is here, and here is where your Z will be attached. When it comes to the second case, aldehyde and acid are at meta position to each other, which means there is only one favorable position, which is meta to both the groups. So that will be preferred. Here no problem, because the directing effects are reinforcing a particular position. so there is no problem. So your COOH come here and Z group will attach here. But when it comes to the third case, I have CHO and COOH at para to each other, right? Right. And the COOH group is the least priority group, which will have greater dominance, which means the Z group will be attached to meta to this COOH group. So this position is favorable. So the major product will be CHO, COOH, and your Z will attach here. So the third one, when one is orthopara directing and another one is meta directing, but the orientation reinforce each other. Here I have OH group and NO2 group. Both orientation will reinforce each other. OH group will direct to para position, and that para position is meta to nitro group, which means this position is more favorable for the substitution, which means my Z group will go and attach at para to my OH group. So this will be the major product. So when it comes to the second one, here OH group is OH group will direct to ortho position because para position is already occupied, and this position is meta to nitro group. So the incoming group Z will go and attach at the meta to nitro group, which is ortho to OH group. So this will be the major product. And the fourth one is when one group is orthopara directing and the other one is meta directing, but the orientation oppose each other, what will happen? See, here I have OH group and COOH group. Of course, OH group is orthopara directing and acid carboxylic group is meta directing. So when we have two different directing groups substituted in the same benzene ring, then the one which is orthopara directing will have upper hand. So it will dominate always the meta directing group. So the incoming group will be directed to the para position, preferably to the orthopara directing group, which means this Z group will be directed preferentially to this position, right? So the major product will be like your OH group will be here, COOH will be here, and your Z group will be attached to the para position to OH. So steric hindrance will also play an important role in deciding the orientation of the third substituent in the benzene ring. When two groups occupy meta positions with respect to each other, there is no substitution between these two groups. That is, this position is less preferable, right? This position is less preferable because of steric hindrance. So whatever the position here, chlorine and bromine I have, both are orthopara directing. They are present to meta to each other, but chlorine will have greater directing influence because it has lone pair electrons greater, right? So the incoming group Z will be directed predominantly to the para position to this chlorine. So this will be the major product. Right. And the Z will get attached here. Thank you. Happy learning.